And we are live. So, in this video, in this live stream, we're going to solve a problem here. So, what I've done is I've pasted a Leetcode problem into my storyboard, which is basically minimum path sum as we see over here. And we're going to do it in the storyboard so that we can manually test it and we can really focus on the problem solving aspect of it rather than the lead code part of it, right? So that's how I'm going to approach it nowadays is I'm just going to paste my lead code problems into a Swift storyboard. At the end of the day, it doesn't really matter, but this is the way that I've been advised to kind of problem solve, So that's exactly what we're going to do here today. So I'm going to quickly check my audio, make sure that it's working on our end here. So give me a moment while I look into that. If you guys can hear my audio properly, hit 1 in the chat below. So feel free to do that, but I'm going to quickly check that on my end as well. So let's have a look over here. And as well. So let's have a look over here. All right, so it looks like our audio is all good. So I'm going to begin my storyboard here. So given an m by n grid filled with non-negative integers, find a path from top left to bottom right, which minimizes the sum of all its numbers along the path, right? So some key notes here. We are guaranteed that we're starting from top left to bottom right, right? So minimizes the sum of all numbers along its path, right? So let's see here. Let's jot down our thought process here. So start at top left, go bottom right, can only go down and right. Okay. And minimizes the sum of all numbers along its path, right? So you can only move down one or right at any point in time. So let's see here. Let's try to visualize this one over here. So what I'm going to do, we see here 131, 151, 421, right? So let me go to online whiteboard. Two, one, right? All right, so we have our whiteboard here. We have 131. We have 151. And we have 4, 2, and 1. So considering that we only are able to go down and left, what we need to do is, if we start over here, first we're going to try here, and now our current sum at here is going to be 4, right? And then we try here, so our current sum is now going to be 5. And then we go down here, and now our current sum is going to be, say, 4 plus 5 is 9, right? And then, let's see, we go down and left here, so 9 plus 1 is 10. And then 9 plus 2 is 11. And then we have 9 plus, so once we hit the bottom one, we can see here that it's 12, right? So that's one path, right? Another path that we might have is 5 plus 1 is 6 plus 1 is 7, right? So we have 7 and 12 as one valid combination. So we go over here to 1. 1 plus 1 is 2. 2 plus 5 is 7. We have 2 plus 4 is 6. 6 plus 2 is 8. And then 7 plus 1 is 8 here. And then 8 plus 1 is 9. So that means we have 9 here. And then 8 plus 1 is 9 as well, right? So let's see, have we exhausted all our combinations here? We have. So we have 7, 9, 9, and 12. So that means our minimum element is going to be 7, right? And that's the answer that we're supposed to get. So let's do the same thing with the other one, which is 1, 2, 3, 4, 5, 6. So let's see how that works out. 1, 2, 3, 4, 5, 6, right? So let's start at 1 and at 6. So what we need to do, 1 plus 4 is 5. 5 plus 5 is 10. 10 plus 6 is 16, right? That's going to be one of our ending variables, right? And then 2 plus 5 is, so 1 plus 2 is 3 rather. 3 plus 5 is 8. 3 plus 3 is 6. And then 6 plus 6 is 12, right? And then we have 8 here. 8 plus 6 is, I do not know how to do mental math, so 8 plus 6 is 14. Right? So 12, 14, 16 is 12, I think. Yeah. So let's see. Is that the answer that we get? Yes. So now we can start to brainstorm some potential solutions to this. Well, we see here that the first thing that we could potentially do is a backtracking solution, right? That's kind of the most naive way. And then I'm going to store all the sums in a array here if it reaches the bottom left corner, right? So let's write all of that down here. Where's my playground? If the bottom left cell is hit, add it to the array, and at the end, take the minimum of the values. So the question is, how do we actually do this? Well, one of the things that I have in mind is going to be backtracking. Now, with backtracking, you could probably optimize it using dynamic programming if you decide to memoize it at a later point in time to improve time complexity, but backtracking is kind of our naive solution. So the way I want to organize this is we have our driver function, and we're going to launch a helper function taking in point X and point Y. So our base case is going to be if the point is out of bounds, then we simply return. Now, in terms of whether we want to have it to return a integer value or to return just a Boolean value, I think in the backtracking solution, we're just concerned about populating our answer array, so it's not that big of a deal. But when we do end up memoizing it, we want to keep that in mind, right? So what we're going to do is we're going to have a current sum variable. So base case 2 is if the cell is at the bottom left, or bottom right rather. This should be bottom right. Yeah, bottom right. Is at the bottom right corner. Append to the answer and return. So let's see, we can make two, and then we also have to have our visited set as well. So launch visited set, and then that's going to be part of our base case. Or the cell is in visited, then we simply return. That's important there. Let's see. Actually, I think the best thing to do is to just do the dynamic programming off the top, right? Append to the answer and return 0. So actually, we're already storing it in our memoization array rather. So if the bottom right corner, append to the answer and return the minimum of the cell. Okay, so now we can deal with the driver function. So define a cur sum variable starting at our grid at x and y. Then we're going to add this current sum variable in the down direction. And we forgot one thing. Add to the visited set. So we're going to add this cur sum variable in the right direction. And then we visited add this cur sum to our memoization array, and then return the memoization array at the point. Outside of the function, we're gonna return, so we're gonna call the DFS function, return the minimum of memoization values. I think that's how I'm going to do it. So let's see. Let's implement it now. So we have func. Min path sum grid integer, and then we're going to return an integer value. So var visited is a set of strings. That's fine. Let's see. It's going to yell at me for that. So var memo is equal to, let's see, what do we need memo to be? We need memo to be our coordinate and an integer. And then we also have to define the coordinate struct as well. And that has to conform to hashable. And this is just so we can store the coordinates in both our visited variable, right? So this is not a string anymore. This is going to be a coordinate. don't care about that. All right, so we have memo. Are we missing anything? Curse sum we do need. I integer j integer, and then we have curse sum, which is going to also be an integer, but this is going to be an in-out integer, so it's not a let constant, it's a var constant. So we also need to pass in the visited, and that's going to be a set of our coordinates. All right. And then for now, we're going to have the integer there, or I'm just going to pass on that. So we also want to have let rows equals grid.count, let calls is equal to grid 0.count. That's going to help us with our calculations. So if I is less than 0, or I is equal to rows, or j is less than 0, or j is equal to row columns rather, or visited dot contains coordinate at I in j. We're simply going to return. Let's see if we have everything we need. If I is equal to rows minus 1, j is equal to calls minus 1, memo curse sum, all right, I think that's correct there. So how am I going to do this? Grid ij if memo coordinates I j is not nil, return make it an optional so I can check it. Your description doesn't even say what language you're writing in, doesn't give any info, what tools you're using, nothing, bro. So I think you missed the first part of the chat, but I'm doing things in a storyboard. So this is Swift. So if you look here, minimum path sum. So my mentor advised me that I should be doing it in a separate coder pad in order to work on the problem solving aspects of things, right? So that's what we're doing, and this is going to be in Swift, as you can see over here. So that's a language that we're going to be using here today. And the tools I'm using is Swift Storyboard. So all you do, go to Xcode and then create a new storyboard. So that's what I'm doing over here, right? Okay. cur sum DFS I plus 1 j cur sum and visited DFS j plus 1 cur sum visited oh, I forgot in out. I'm going to force unwrap it here because it's guaranteed that it's nil. So source stops yelling at me. Coordinate I, j. This should be equals cur sum. And we return the minimum of the current sum. Int.max ants is equal to min of ants incurred sum, return ants. Oh, var hey, hey, hey. Zero, zero, current. Zero, zero, cur sum visited. Now I have some convolution errors I have to deal with. Memo.values is oh shoot, I forgot to add test cases. Okay, let's see. That's not the answer that I want. All right, let's go back to our old solution here. So var ants equals integer, then you take the min of the integer values. What I want to do, ants.min, I believe. And all we have to do is handle the error there. So ants.min, kind of set that up. Now I have to deal with the kern sum stuff. Grid ij, because you have to go back. So cur sum grid ij visited dot insert coordinates xy, which is I and j, dfs ij cur sum visited. So that's going to be I plus 1 j cur sum visited dfs I j plus 1 cur sum visited. I got everything. Yes, I did. No errors. Okay, I is equal to rows, j is equal to columns. Cur sum is cur sum. Just want to check the values there. Zero. Let's see here. What's going on? Current sum is 1, 2. Let's see. Let's compare that to my diagram here. One, two, three, four, five, six. So it's not hitting my second base case is the problem here. Oh, that's why. Rows -1, calls -1. So 1, 2, 6, 8, 8, 13, 13, 15, 16. Interesting. Interesting. One, two, six, eight. Let's see what it's doing here. Eight plus 1 is 9. Okay. I see what's going on here. So we forgot to add the current cell to current sum. We got 9. So let's see. One, two, six, 8. Answer's 9. I don't think this is correct. So let's compare that to my diagram here. So what path is it taking here? 1, 2, 6, 8. So 1, 2, 6, 8, 9, right? So that's kind of what it's taking right now. Eight and then 9. So it's getting that combination, but it's not getting anything else. How's it getting 15 is the question. Current sum is current sum, okay. Visited dot remove coordinates xy I j cur sum grid I j. Let's see what she does. Nine, 11, 11, 15, 15, 12. Let's see. 9, 12, 7, 9. Interesting. Getting closer, but not quite there yet. Where is my playground? I have way too many tabs open. What would happen if I did curse sum there? No, we definitely need that additional curse sum there. Bottom right row is curse sum. Path traversal is 1, 2, 6, 8, and then 9. Curse sum at the bottom right row is 9. So we have 8. During path traversal is 8. I'm going to print out the path as well, so I know exactly what's going on. Path is an in-out integer, and then Swift is going to yell at me for that, so path, and then we're going to add path as well. There we go. Path.remove last. Path.remove last. Oh, debugging. Path, let's see. So we have 1, 1, 1, 1, 1, 4, 1, 1, 4, okay. 1, 1, 4, 2. And then 9. So 1, 1, 5. 1, 1, 5, 2. Prints 2 is path. Curse sum during path traversal, 1, 1, 1, 1, 4, 1, 1, 4, 2. Oops. 1, 1, 4, 2. 1, 1, 4, 2, 1. Okay, that's right. We don't need this curse sum at the bottom row anymore. Just going to rerun it here so I have less print statements. Okay, current path 1, 1, 1, 1, 1, 1, 1, 4, 1, 1, 4, 2, 1, 1, 4, 2, 1, 1, 1, 4, 2, 1, 2, 1, then 1, 1, 5, 1, 1, 5, 2, 1, 1, 1, 5, 1, 1, 1, 1, 5, 1, 1, 1, 3, 5, 2, 1, 1, 3, 5, 2, 1. Okay. 1, 3, 5, 1. So 1, 3, 5, 1, 1. Oops. 1, 3, 5. So 1, 3, 5, 2, 1. So 1, 3, 5, 1, 1. And then lastly, 1, 3, 1, 1, 1. So it looks like the path is all being appended correctly, but let's see what's going on here. 1, 3, 1 plus 3 is 4, 5, 6, 7. So it looks like the curve sum somehow is going wrong. But the logic is there. I'm going to do this the lazy way. So instead of doing curve sum, we're going to remove this curve sum variable here. Do it the traditional way. some path. Let me just current path is that. Cursor, remove that. Visited.insert, okay. Reduce. Let's see what she does. Oh, where's cursor? Oh, there it is. Yes, sir. We got it. We got it. We fucking got it. Okay. Example 2 now. Oh, shit. Yes, sir. Yes, sir. Okie doke. So now that we kind of have a solution, we can put it into Leetcode and see what she does. So Swift struct coordinates hashable, let x to be an integer, let y to be an integer. I like to do it this way because it makes my problem solving a lot more easier, shall we say. And then oh my god. We don't need memo right now. We don't need cursum. Let calls equals grid0.count var ans is equal to an integer value. Var path is equal to an integer value. Okay, copy paste that. Okay. And then return ants.min 0. Hell yeah. Let's see what the Leetcode judges say. And of course, we have time limit exceeded, so we have to use dynamic programming. Hooray. So, obviously, we got kind of the concept here of backtracking, but there's still optimizations that need to be made here. That is, if our backtracking solution works, now what we need to do is we need to optimize it so that it becomes dynamic programming. As you can see here, DP. Oh, fuck, I hate DP. Okay, so we definitely need our memoization array. So, okay, so dynamic programming. How do we do this? So DFS I J and then visited path. Okay, so I want to replicate what I have here. True. Oh, shoot. Yep, so that's verified to be true. I'm going to borrow the house robber solution that I've done previously. So return 0. And then if we're at the end, we're also going to return 0 as well. Okie dokes. Let's see what she does. And I'm going to remove this 7 here. Let's see. So down, left, path, remove last, visited, remove. Oh, I'm stupid. J. So it's not actually doing anything. Oh, dynamic programming. Yeah, that's definitely not the right answer. Oops. Let's ask AI because I have no freaking clue. shoot. Ay, 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 ay. This is what I hate about DeepSeek. Ay, 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 ay. let's see. Five. Two, four. All right, so I'm gonna end the stream. I gotta go do something, but hope you guys enjoyed, and I'll see you on the next one.